Okay, guys, so now looking at Unit 15 here, we have graphing two variable inequalities. So this is going to be kind of similar to when we graphed linear inequalities or linear equations, sorry, but also kind of similar to our inequalities unit we just finished, okay? The first thing we want to look at is graphing the boundary line. Okay, this boundary line is something we're used to graphing. We're not used to calling it that. We only call it when we're dealing with inequalities, okay? So the boundary line is essentially what we're going to graph. This is lines like we're used to seeing in slope-intercept form, for example. Okay. The next thing you're going to do is you're going to test a point that is not on that boundary line. Some are easier to pick out than others. Okay. The first thing you want to do with that point is if it makes the inequality true, you want to shade the half plane that has that point in it. But if it makes the inequality not true or false, okay, you want to shade the other half of that plane. Okay. Now, I know that might seem kind of vague right now, but look at some examples here, and hopefully that'll clear some things up. Okay, the first little table we're going to look at here is less than or greater than. If we have a less than or greater than inequality, then it's a dashed boundary line. Okay, if we have less than or equal to or greater than or equal to, it's going to be a solid boundary line. Okay, so our first example, we have y is less than or equal to negative 3 over 4x plus 7. Y is less than or equal to negative 3/4 x plus 7. So we are in slope-intercept form here, okay? We're used to seeing equations in this form where we have an equal sign here, and we're in slope-intercept form, okay? Now we're dealing with an inequality. Y is less than or equal to negative 3/4 x plus 7. So if we look at this, we know our y-intercept is the point 0, 7. We know that because this is in slope-intercept form. So 7 is my y-intercept. Now if I want to graph the point 0, 7, that's where it's at right there, okay? Now, the next thing we know from this inequality is the slope. Slope is change in y over change in x, or some of us know it as rise over run. Okay, it's negative 3 over 4. So we're going to go down 3, right 4 from our y-intercept point that we have over here. So we're going to go down 3, 1, 2, 3, right 1, 2, 3, 4. There's a point right there. Down 1, 2, 3, right 1, 2, 3, 4. There's another point. Down 1, 2, 3, right 1, 2, 3, 4. Okay, we want to go till we can't anymore. Now, what kind of line are we going to use to connect these dots? Hopefully you all said a solid line because this is less than or equal to. Remember, if it's less than or equal to, it's going to be a solid line. Okay, so there's our boundary line right there. So that's something that we should be familiar with, graphing a slope-intercept form line. Okay, now the next thing we were supposed to do is pick a point that's not on that line and see if it makes the inequality true. So an easy point that we can pick that's not on this line to see if this is true is the point 0, 0. Okay, so we want to test the point 0, 0. So that means we're going to substitute 0 in for x and 0 in for y into our inequality and see if it's true. Okay? So if we look now, we have 0 is less than or equal to negative 3/4 times 0 plus 7. Okay? So 0 is less than or equal to negative 3/4 times 0 plus 7. Negative 3/4 times 0 is 0. So we're going to get 0 is less than or equal to 0 plus 7. Of course, we know that 0 plus 7 is just 7, right? So we would be left with 0 is less than or equal to 7. Now we want to look at this and see if this is true. Is 0 less than or equal to 7? Yeah, it is, right? So that would be true. So we would shade the half plane that contains that point. Now you might be wondering, what's the half plane? This part right here that's below the line is one half of the plane, and this part above the boundary line is the other half of the plane. So we have a part above it and a part below it, okay? Since this test that we picked 0, 0 right here makes the inequality true, we want to shade that half, okay? So that's what we do. We shade that half there. So this is what it looks like to graph inequalities, okay? We started with putting our y-intercept, which we know how to do, and we started with using our slope to go from there and fill out our points and draw our line. We knew our line was going to be solid because it's less than or equal to, okay? And then we pick a point and we test it. And that test just so happened to be true, so we shade that half, okay? So that's what it looks like to graph those inequalities. Now, if we go to number 2, we have y is greater than 5 halves x minus 3. Okay, so we're going to go through the same process here, okay? Y is greater than 5 halves x minus 3. So the first thing we want to do is identify our y-intercept. Our y-intercept is 0, negative 3, which is right there on the graph, okay? 0, down, 1, 2, 3. Our slope is 5 halves, which means we have a rise of 5 and a run of 2. So we're going to go up 5. 1, 2, 3, 4, 5, and right 2. 1, 2. Okay, there's our next point right there. We're going to go up 5. 1, 2, 3, 4, 5, right 2. There's our next point right there. Okay, now this line is strictly greater than. So hopefully we recognize that. What kind of line are we going to have here? Okay, hopefully you guys all said a dash line because it's strictly greater than. Right? If it were greater than or equal to, then it'd be solid. But since it's only greater than, we would have a dash line for our boundary line. Okay, now looking at this, we need to test a point. Again, another easy point that we can test that's not on this line is 0, 0. So let's test it again, right? That was pretty easy last time we did it, so why not do it again? So we're going to end up with 0 is greater than 5 halves times 0 minus 3. And of course, 5 halves times 0 is 0. 0 minus 3. We're just working on this right side here because this is the side we have to simplify. We can't really do anything else with the left. We get negative 3. So 0 is greater than negative 3. Is 0 greater than negative 3? Okay. 0 is, in fact, greater than negative 3. Okay, so that would be true. So we want to shade the half plane that contained our point that we tested, 0, 0. So 0, 0 is here. We want to shade this side of it right here. Okay. There's the shading. Okay, and that's it for this first section of notes, guys. Okay, there's a practice on delta math for you guys to work on, at least for my class, on May 12th, Friday. And let me know if you guys have any questions.